I just wanted to illustrate some of the things that we've learned about LTI systems, specifically this idea that LTI's output is equal to the convolution of its impulse response with its input. Okay, so here I've got a little demo, and what I do is I have some input. The input sounds like this.
Where were you while we were away?
Okay, and then what I do is I have a little impulse response. This is actually one that I just basically constructed by hand. It has an impulse at 1, and then it has an impulse, I can't remember exactly what the value is. The value is 0.7. It has another impulse 2,500 basically time steps later on. It's that high because the sample frequency of this signal is quite high. So what I have is I have this input.
Where were you while we were away?
Okay. Then I have this hand-constructed impulse response. And what I do is I take this impulse response and I convolve it with that input. Okay. This is a little SciPy function that does the convolution for me. I'll actually unpack that a little bit later on. And then we can just listen to the input. So what I do is I take this input.
Where were you while we were away?
I convolve it with this thing, and this is the output.
Where were you while we were away? Where were you while we were away?
Okay, so what's happened here is that this linear time invariant system, it adds a little echo. And you can already see that if I'm convolving this impulse response with my original signal, remember I take this, I flip it, and then I sweep it across, then what's happening is I'm basically copying some of the samples that happened before at the current output, and that's what's causing this echo.
Where were you while we were away?
Okay, I've got another song, one of my favorite Rise Against songs, so I'll just have to play that as well through the same system. Okay, so it's the same system. This is the input. Okay, and then if I play it through, I pass that input through my system with this impulse response, then I get this output. Okay, it actually sounds quite similar. So what I'm going to do is I'm just going to move this delay a little bit further on. So I'm going to make that 5,000. Okay, so now that's at 5,000. Listen to the drums now. Okay, that's pretty cool. Okay, drums here. Okay, and then the drums here. Here, da-dum. Okay, cool. Let's do multiple echoes. So what I do here is, I'll just start with the male voice again. And then what I have is I have this little impulse response, which I use to process my input. Input, just as a reminder.
Where were you while we were away?
Okay, and then the output in this case.
Where were you while we were away?
Okay, so now there's actually multiple echoes that comes from convolving this with the input. Okay, so we are basically copying little delayed versions, little delayed attenuated versions of the original signal over itself. Okay, last but not least, I actually mentioned this in the video as well. Let's say we actually want to model what happens in a room. Okay, so we've got some room. Maybe it's some fancy auditorium where we like to listen to music. What we can do is we can go into that room and make a very loud clap, set off a cracker or something, and then record what happens. Now, a very loud clap, that approximates an impulse. And so whatever we record as a response to that clap is the impulse response of that room. Okay. And what we can then do is we can use that and basically convolve that with some other input. What that would give us is it would basically show us how that input would sound in that specific room. Okay, so let me just do this. So this is a clap that was recorded in a room. It wasn't actually a very good room. It was just a reverberant room, so one with a lot of echoes. This is the clap. Okay, so that is the impulse response of the room. Okay, that is the impulse response of the room. Now what I will do is I take some input.
Where were you while we were away?
Okay, and I basically convolve that with my clap, and then what we get is this.
Where were you while we were away?
Okay, sounds pretty legit. It sounds like someone said those words in a room. Let's just take my song as well, always important. Okay, here's my song. Okay, and then in this room, this is what the song would sound like. Okay, maybe not a room where I would want to listen to that song, but I hope you get the idea. And this is the coolness of LTI systems.